classes are telling me that, their classes are not doing it. I'm proud of you there. Now, some of my students stop by at 4 o'clock to get a little preview of what's coming up today. And guys, I'm going to get a connection with what we were doing last week, connection to what we do today. And then you have a short quiz on Wednesday, and I mean short. It's 10 points. Now, if you look at the syllabus, I did this on purpose, because I know what's coming up. This Wednesday coming up is a 10-point quiz, short quiz. The following Wednesday, another short quiz. The following Wednesday, another short quiz. And the following Wednesday, you'll be on spring break. So the next 3 Wednesdays, if you look at the syllabus, are all quizzes. So you will not have another exam. I planned it like that when I did the syllabus, because you'll have your exam, your third exam, the Wednesday after you return from spring break. Okay? So that's a little bit of time there. Now that's going to give you some relief. You've already had 2 exams from me already. Some instructors have just had a chance to do 1 exam. We've done 2 already, so you guys are way ahead. So the following 3 Wednesdays will be a little bit of a relief, maybe a 30-minute quiz, so we should all do well in that. Now, on this one coming up on Wednesday, what's going to happen is when I start making the connection to what we were doing, the 4 o'clock session is asking, Professor, what is going to happen now? The exam's done. I sort of know something about a parabola. I know the vertex form. I know how to complete the square. I know all that, Professor. What's going to happen? So what's going to happen is this. They point out in the textbook that maybe what would happen if they ask us to do this. Write the equation. They write the equation of what? We go back to a parabola. So in other words, now what's coming up in the next section here I'm going to discuss tonight, I have a nice handout here also for you. They will give the graph to me. I don't have to graph it. They'll be given to me. For an example, if we have, the graphs are being done for me. I don't have to worry about finding the x-intercepts, the y-intercepts. I don't have to find or complete the square. I don't have to go through all that. All we have to work with here is this. A parabola is going to be given. Now, and the rest is write the equation this graph came from. So guys, I am going to point out a few items that may help me. It would be a big help if I knew where this vertex was. I hope they identified for me. And I need numbers here. Let's say this one's out, maybe out 2, down 3. Those are the coordinates of the vertex. In this case, it's a minimum. And then maybe also for a reason, I may give you another point to work with. You say, Professor, I'm going to give you another point besides the vertex. I thought that was enough. But you're going to see, maybe you need another point. Point, do this right here. Add another point. Guys, let's say this is out 5, up 2. For coordinates. And they asked me now, write the equation that this parabola came from. All I know, and all you know right now about a parabola and the equations would be, you may say, Professor, it must have something to do with the vertex form. So I'm going to jot down what that vertex form looks like. And you guys have seen that before. You saw it on the exam. That's the vertex form. Where the vertex has been identified as, if you put it in this vertex form, it has coordinates of what they call H and K. That's my turning point. Vertex. Could be a max or a min. It all depends on the A value. Also, coming up, I better not forget that a standard form for a quadratic looks like this. AX squared plus BX plus C. We've seen both. Vertex form and the standard form. Now, with that little bit of information, can I, with your help, turn to one of those forms based on what you're given here, and maybe use one of those forms, eventually maybe use both of them, to come up with the equation for that parabola? Now, which one might you want me to start out with? And I'll make replacements if that's possible, and then start there and get some partial credit. Which one would you like to work with first? Number one or number two? And they're both forms of equations. Guys, which one would you like for me to now try?
One.
Number one? Now if I try number one, right here, which says y is equal to a parenthesis x minus h squared plus k, but here's my h and k that come. This is my vertex, this is my turning point being given to me. So definitely put that in. And look at this, that's why I give you a second point. Here's an x and a y replacement. They give me a lot to work with. So if I go to that vertex form, make those replacements, and be careful, guys, I see the y here is 5. I don't know what the a is. The x is, oh, whoa, whoa. This upside down here. 2, y is 2. A, then x is 5. Subtract h is 2. Now I'm all over the board here, don't you make a mistake here. Plus k, and k is -3. I'm just going to call that -3 here. And step back and look at it, guys, and see if you agree. Did I put the numbers in correctly? The vertex and the point I gave you to work with. So let me check my replacements correctly and see if they are correct. And I think they are. You guys agree? The numbers we put in? Now, is that enough for me to go across the street and solve for A in the middle school? Well, of course it is. Got 2 is equal to, inside here is 3, so that's 3 squared 9, so that's 9a. Subtract 3. And now can I solve for A? Easily done. We end up with 5 is equal to 9a. A is equal to 5/9. Step back and look at it. I did it quickly. Do we agree? Now, would that be enough to say now one type of an equation for that blue graph, Professor, would be this. Y is equal to, here we go, 5/9. That's my A value. X subtract, I think we had X subtract, in this case H was 2. X subtract 2 squared minus 3. Could that serve as the equation for this blue parabola? Is that true, guys? And we have the equation written out. Now, if you want to put it in this form, if I say put it in standard form afterwards, what would you have to do to place this vertex form, if everything's in there correctly? Change that vertex form into standard form, what might you have to do? Which may take a little time. What do you think? How can I change the blue, which looks nice, if there's no mistake here, into the black? If I say put it in standard form, what would you have to do? How can I go from vertex form to the standard form? Shame on you. What would those kids across the street do?
Multiply it out.
Well, of course, they want to expand this thing out, make this x squared minus 4x plus 4. That's middle school. Distribute 5/9, middle school. Subtract 2, a little bit more middle school. And you clean it up and make it the best you can like this. Are we okay? So how on earth can you go wrong on Wednesday? The parabola staring at you, you don't have to graph it. And I give you a little detail about the parabola. Then you could easily work with the equations and come up with the equation. Is that true? Now, if I were you, if you have time on Wednesday, I'd say, wait, now you know that 5/9 is a strange number. I may have made a mistake, Professor. It's a strange fraction. What I would do is quickly say, well, hold on. If that's correct, if I replace x by 5, for example, just for a little check. X was 5 here. If I put 5 in here in my form, 5 subtract, what was that, a 2 there? 5 subtract 2 is what, 3? 3 squared is 9, the 9's would cancel. 5 subtract 3 gives me a 2, and it was a 2. And I can do the same thing down here on the vertex. Replace the x by. Is that true? Is it only on Monday, or you guys are saying, yeah, it's true, Professor, move on? Is it true? So you could actually check it here. Now, I'm not going to expand this thing out. You could, if you want to put it in standard form. Now, my students in my 4 o'clock session said, Professor, can they get any harder than this? Well, part B. Mr. Park, Anna, I've got them started. Now I want to do this. want you guys to have me pass these out.
Okay.
Thank you. Okay, guys, look at the side of the handout when you get the handout that has those parabolas drawn for you. And I think there's one more I want to look at. Just probably keep one copy for yourself. Just look it out. Okay. Now the other one, a little bit more of a challenge. I have only 2 graphs here. By the way, I should have, I think was the one opening down? The first graph opening down? I mean, the first one on the handout. Is it opening down? I did opening up here for my example. I think the one on the handout, that's one open down, wasn't it? Okay, it's worked the same way as mine. Same way, same replacements and so forth and so on. Same type of a situation, not the same answer. But the one I'm gonna look at now is a little bit more challenging is, suppose, Professor, you have this. Again, you have a parabola. And this time, looks like on the handout, we make it look as much like the handout as I can. Looks like this. Yeah, there's another one opening up. And it looks something like this. I see the y-intercept is -1. So they have this labeled for me as 0, -1. And looks like, yes, it goes through here. Goes through the y-intercept, comes down, drops down, comes back up. Now, let me make this, there's the hole here. It looks something like this. And as it does that, -1 in there, make it a reasonable here. Here we go. That does something like this. Back. Something like that. And I threw in a couple more points here though. Looks like it's out 3, up 5 is on here. And looks like it's -1 or -2, is it? -1. Up 5. That's all been given to me. And looks like 0, -1, yes, that's what I wanted. They did not give me the x-intercepts. They did not give me the vertex. Now guys, is that what it looks like on the handout? The graph itself. Do I have everything marked correctly? Okay. And they want the equation. Okay, here we go. I have again, if I use it, the vertex form. Can I make replacements in that? Can I maybe use the standard form? On this one. Okay, so if it looks something like that, here we go. Now I approach this one over here, a little differently. Now, can anyone give me some input onto or how to approach this, where this time the vertex, which was given to me on this one, the vertex, the turning point's missing? What might you do? And you would write the equation of that parabola opening up. And I'll do it right here, it's missing. The vertex missing. So can I turn directly to the vertex form? No, I don't have the vertex. So give me an idea, guys. And the other form I think I gave you was the standard form. F of x is equal to ax squared plus bx plus c. The form I only have here is, absolutely, y is equal to ax squared plus bx plus c, standard form. I can make some replacements there, if I wish. In fact, I can make a lot of replacements. They gave me an x and a y here. If everything is copied down correctly. They gave me an x and a y here. If I need to use it, they gave me an x and a y here. But they did not give me the brackets. Any ideas? Go for it.
With the 2 points you have, with negative 1 and 5 and 3 and 5,
This is negative 1, 5, 3, 5, you have something in mind to do. What are you going to do?
you find the middle of both terms, get the x values of the
He's being clever. He says, Professor, I think the midpoint, the point in the middle between these 2 points, if I can find it, might help me find this down here. Is that true? Would you guys agree? Maybe the midpoint? And by the way, now the midpoint, he's talking about up here. The midpoint between those 2 points that are on the parabola. Guys, to find the midpoint, what should I do to find the midpoint? Add the x's up, divide by 2, then add the y's up, divide by 2. If I add the x coordinates up for those 2 points, if I have this labeled correctly, negative 1 plus 3, what is that, 2? 2 divided by 2 gives me what, 1? And if I add the y's up, 5 plus 5 is what, 10? It gives me here, what, 5? So they all line up. He says, Professor, line these up like this. And guys, I'm gonna step back and see. Do you guys agree maybe that, is that the midpoint caught between those 2 points? Now, he says that has something to do with what I'm looking for. If you wish, I think that's what he has in mind. Something to do with this vertex. Is this what you have in mind? So what can I do with the vertex knowing the midpoint is 1, 5? What do I know about the vertex now? If anything. The x coordinate. Is the x coordinate 1? With his reasoning. So now you can say, hold on, Professor, if you need the coordinate for the vertex, I think the x coordinate with his reasoning is 1 from that midpoint. The y coordinate is missing. I need both. Now, can anyone be clever and tell me another way, which is beautiful, I love that midpoint. Is there something I could probably continue with what he told me and continue with it and eventually end up with what I need? And then write the equation? Aaron, you got any suggestions? No? Anyone else? Any suggestions? Now this made all kinds of sense. I love what he's doing. You find the midpoint, that midpoint, that x coordinate must be the x coordinate of that vertex, which is my turning point. If I now find the y coordinate, we'll be in good shape. You go back and write the equation. What do you think? Is it 1 comma negative 2? Is it 1 comma negative 3? Is it 1 comma negative 1? Are we just guessing? Any ideas? Okay, I'm showing the approach that I would take. See if you guys will agree with this. I'm going to look at, since that vertex is missing, I'm going to stay away from this right now. I cannot go directly to it and put it in the full vertex, H and K. I'm going to go to the standard form on the side here and say, well, the standard form, if I can't use the vertex form, looks like this. And Professor, they gave you a lot to work with. You couldn't work with 3, 5 and make a replacement here. Let x be 3 and y be 5 and put that in. If I do, you end up with this. And we go ahead and clean that up. So guys, I'm using this point right here, which was given to me. In this form, you end up with 5 is equal to, let me clean this up right quickly, 9a plus 3b plus c. Block that off. In fact, I'll clean that up a little bit here. But that, later, is what I have right now at this point. Is that true? Now, do they give me more to work with? Could I also work with this point over here? If it would help. Yes, no? If I go to the standard form to make another replacement, let's call this step one. Step two, this point's been used. Oh, this point can be used. This is another X and Y replacement. If I do it there, I'm gonna end up with what? 5 is equal to A, -1 for the X. -1 plus C. And I'm gonna write this as, guys, it's gonna be 5 is equal to, don't let me mess up here, it's like 1A minus B plus C. Let me step back and look at it, see if you guys agree with that. Is that true? Did I put the numbers in correctly? Now, does anyone see anything with those two equations that maybe I could do with this, that you probably did somewhere back in middle school somewhere, with equations that look like this? They're stacked up, they're called a system of equations. Does anyone see anything at all that I could do here in an effort to solve for A or B? Because I think the C's are gonna cancel out. Could I easily subtract those two equations? They're stacked up, it's like a system of equations. Could I easily put them together by subtracting them? They're lined up, and that would definitely make the C's drop out, which would help. And I can now change it into, put it in red here, guys. If I subtract them, guys, is that gonna be what, 0 here? Help me out. Is that 8A plus 2B or not? Yes. Let's see if you guys agree. I did it quickly, and I'm gonna see if somebody sees it. Can I do that by subtracting and end up with that? And will the C's drop out? If I subtract the two equations, let me do it right here, and see if someone catches a mistake. If I subtract, that means change all these signs. Then put them together, the 5's do drop out. You're going to end up with 8A, is it? What happens with the B's? Is that 2B or 4B? If I combine these two equations, after I change the sign, is this supposed to be 4 there? And then do the C's also cancel out? Is it true? If I line them up and subtract them, so I got that. Oh, this is partial credit, but I'm not down to where I should be yet. That is true. That's no problem. Now, help me out. Where you gonna go from there? I put my 2 points in, I did the best I could. Then what can I do from here? Michael, remind me on this one, is this all they gave me with these 2 points up here? Vertex is missing?
Leave the y-intercept.
I have the y-intercept on the, or the x-intercept.
Leave the y-intercept.
Okay, the y-intercept on, help me out. This right here. They give me this. So what can I do with 0, -1, which I haven't touched yet? What can I do with 0, -1, besides what I've already done on the side here? Guys, I think I used these 2 points. Let's make sure I put these in. I think I used these 2, didn't I? Did I use those 2 points? I need to hold on, Professor, there's a y-intercept there, right? What can I do with 0, -1? I need some help. How can I find? Something else I need. I need to write this thing in standard form or vertex form. If I can find the vertex, and by the way, I might have one student tell me, Professor, these are the coordinates of the vertex. I don't know what the y is. You got me out with the midpoint. Now what? I've got 0, -1. What else can I do? You saw what I did with this point. I took these coordinates and put them in here. You saw what I did with this point. I carefully put them in here. Is that true? And I got these 2 results, and I thought, hold on now, if I actually subtract these 2 equations, I'm going to end up with this to look at. 8A plus 4B is equal to 0. 2 dropped out. Is that true? Now what? Why on earth would you give me something like this, find the equation? where they give you the graph and ask you to write the equation, all of a sudden, we don't have the equation yet. But they're saying there is an equation that will satisfy all three of those points, plus the, and we'll find the vertex eventually. Guys, any ideas? You guys were with me at 4 o'clock, did we do something like this also? By the way, could I take the point that's still remaining 0, -1, suppose I put that in here? Let the y be -1 and the x be 0. If I do, something will happen here. Now, go to my remaining point, and write this as what was that? -1 is equal to a 0 squared. Just mark up 0 squared plus b times 0 plus c. My goodness, what's that to me immediately? C is equal to a -1. Oh, I now know what C is. Now what? I finally found C by using that third point. And I need some input, we're getting awfully close to what they want here, they want the full equation, I need the A, B, and C, we found C, yes.
Could you, in the equation that's in red, could you solve for B and plug what you get back into it earlier?
Okay, tell me again,
The equation that's in red, could you solve for B and then?
you mean solve for B here?
Solve for B there and then plug what you get back into it?
I could solve for B, absolutely, if that would help, guys, I could solve for B. And I could get B by itself, I mean, do what you're suggesting here. If I solve for B, you're gonna end up with, let's move that 8A over, and you got this. And then divide by a 4, or you tell me you have sort of like that in mind? For B?
And then substitute.
And then you wanna substitute it where?
For B earlier, solve for A.
Okay, back up here maybe? Back up here maybe?
Sure, yeah.
Okay, here we go. Let's see what's gonna happen. So he said, Professor, go back to the first equation, 5 is equal to 9 times A, 9A, plus 3B, but in place of B, Professor, put this. If this will work. Okay, what's it here? So there's some thinkers in here, -2A. If that will work, that's a B replacement. And C, I just discovered C is -1. I can back replace C. Now, is that enough? Let's see if it is. We'll end up with 5 is equal to 9A. Guys, I think it's what, -6A? -1. Step back and look at it, I'd write this as 5 is equal to, let's call that 3A -1. Now, can I finish this thing up, solve for A? I think A is gonna be equal to, if I move things over, guys, what's that, 6 is equal to 3A, help me out. Is the A 2? After all that effort. Yes, no? So I got A to be a 2, C to be, -1. If I need it, can I get B, if I need it? Yeah, B is equal to, right, it is, -2A, so it's a -2 times A. I hope that A replacement is correct, that's another 2 equals B, so it looks like it's a -4 equals B. There's another replacement. If everything's been put in correctly. Do you guys agree? Now can I write the equation? My goodness. Let's see how much I need here. We think the standard form looks like this, guys. Y is equal to, we think A is, help me out, what was the A value? Was that 2? So 2x squared. The B, just found the B is a -4, that's a -4x. And C, of course, fell out nicely for me somewhere over there, -1. Wow. What would you do as a clever student, because you saw so much going on in that conversation? What would you do as a clever student after you finish it up and say, Professor, I think I finally have it. I have an equation for that parabola. What might you do yourself to make yourself feel a little better before you turn that quiz in. I would check it. They give me 3 points. All 3 points should be satisfied. If not, there's something wrong here. And also, I'm gonna check his little midpoint, item we mentioned. Guys, let me see what's gonna happen. Let me check this point right here first. If I replace x by 3 in this, I should get a 5. If I put an x to be 3, that's where it goes. I'm gonna check this right here, this is like a little check. That means 5 should be equal to 2 times 3 squared, subtract 4 times 3, minus 1. What is that, 18? Subtract 12, subtract 1. Please tell me, is that 5? Did I do the math correctly? That's a check. So my equation there has that point satisfied. We check this one. Now let's check this one. I'll do it up here on the side. Same equation. Y in this case is 5 again. And this time it's 2 times -1 squared. Subtract 4 times -1 minus 1, I think it was. So if I can look at it, make sure that's put in there correctly. Guys, if I clean this up, this is what, 2? Okay, 5 is equal to 2 plus 4 minus 1. Please tell me, is that 5? Does that work? Now the big one. Does the vertex work? Well, we don't have the complete vertex yet. Now, how can you tie this in with what you did on the exam that I just returned to you? How can you tie this in, and we'll confirm his thought about the midpoint? What might you do now to complete and find the vertex? The y-coordinate of the vertex is missing. How can I do it? Give me an idea. This is missing. Now let's find the vertex. He's telling me through the midpoint, he says, Professor, I think the x-coordinate's 1. Gonna find the y-coordinate. And right now, we have, here's the equation, it's in standard form. The truth. But how could you find the complete vertex? Now, could I use -b over 2a? Was that a -b over 2a being used on the exam? Could I use it? Or could I complete the square real quickly and put this thing in vertex form and make it connect to last week? See, that's the trouble. I haven't seen you guys. Did I see you guys on Thursday? No. Did I see anyone Friday? No. I went out shopping on Friday. I looked around to see if I could see you guys. I didn't see any. Saturday? I didn't see you. Sunday? I didn't see you. Then all of a sudden Monday I see you. I said, Professor, I guess I forgot what a parabola even looks like. By the time I see you again. That's why I'm getting those looks on a Monday. Okay, guys, here's the way I'm gonna close it down. Michael, we'll do this. If we accept, it looks like that equation is going to satisfy those points. Those 2x squared will work out. Subtract 4x, subtract 1. Is the equation at this point. I'd like to put this in vertex form. I'd like to see what it looks like in vertex form. I'm not going to use that -b over 2a business and all that. So guys, in vertex form, based on what you did on the exam, and by the way, one problem that many students did a beautiful job on was the one where I asked you to take the equation and put it in, or the function, and put it in vertex form. You know how to do that. I got to put this in vertex form. The trouble is, of course, that leading coefficient should be a 1. Can I make it a 1? And Aaron, I'm going to take your suggestion here. I showed you a little process myself where I put a blank on each side to see what to add and so forth and so on. Many of my students on the test use that method. Aaron says, Professor, we'll do this. If you need a leading coefficient of a 1, which I do complete the square, he says, go ahead and factor 2 out immediately. And if I do this, guys, and then get ready to find out what you need here, of course, you still got to subtract 1 there. You step back and look at it. So on the x's, I took out a factor of 2, so I'm going to have that leading coefficient now to be a 1. Is that the way we sort of did it? Aaron, help me out. And then Aaron, what you want to take on that blank to make this factor into a nice perfect square. I got x squared subtract 2x plus blank. And I'm looking for something to add on that blank, so this will turn out to be a nice perfect square. And what would that blank have to be?
X equals 1.
1. And usually if you can't stick with that number, you just take 1/2 of this and then square it. Remember doing that little process? 1/2 of this is squared. So you got a 1. Now here's the problem. The original quadratic looks like this. I gotta keep the original. I'm just putting it in a different form. Now right now if I do a check, distributive property, 2x squared, agrees. 2 times a negative 2x, negative 4x, agrees. 2 times 1 that he asked me to add, that's a 2. And my minus 1 agrees. I got an extra 2 showing up. So Aaron's process is to do what, Aaron, at this point, to modify this? You were telling me about this process.
Yeah, -1 again on the outside.
Okay, I'm gonna put a minus 1 on the end. Can I quickly make that 2 drop out by doing this? Subtract it. And then still have my subtract 1 down here on the end. Be a little clever. Now, will all this mess right here, is it naming the same as this? I cleaned up, is it naming the same as this? And why do all this? Aaron says now, Professor, this is y is equal to 2. All this will factor into a nice perfect square, and these 2 is be a -3 now on the end. Is that true? There's the vertex form of that parabola. With Aaron's help with the completion of the square. Now you guys who did not follow what I did here on this, where I just subtract 2, 2 times 1 is 2, subtract 2 to make it drop out, what's up there to begin with, subtract 1, still there, and there it is on the completion of the square. You guys who add the blanks on each side, the little process I showed you, which also works, you can use that and also get to work out. A little bit quicker this way, I think. Now my vertex should be, here we go, vertex should be a horizontal shift of what? 1 to the right, 1, and down 3. Down to precisely the coordinates of my vertex. Out here where I stopped is now 1. His midpoint worked. And now my y is, if there's no mistake, -3. Out 1, down 3. Whew. Please tell me, is that making sense now? Now, I would do this after all this work, and I guarantee you some of my students in class, I've seen the type of work some of my students are doing. You may approach it a little differently, but still make it work out for me. When you do it by a different process, that's fine, as long as the process makes sense. Aaron mentioned to me he does it is like this, I'd like to point out to the class. Now, this last point. This last point should also, if not where we were, let's go check it somewhere. Because it's on the graph. Oh yeah, here we go. 1, -3. Let's see what I did here. Where was I doing all my checking here? Because I think I checked the points here that were originally checked. If I go back to my equation now, and we have it right here. Should that point there also be satisfied? Out 1, down 3. So if I quickly replace y by -3, guys, I'm going to do it real quickly. -3, and the x is by 1, in that standard form, and not mess up here, we end up with -3 is equal to 2 minus 4 minus 1, and I hope that's -3. That's a check. I take the numbers into it. I'm guaranteed, that took a long time to do that. I'm guaranteed though, I have the right equation. Standard form, where is it? Over here, vertex form. I have it in both forms. Standard and vertex. Woo! I'm looking at my clock here. Oh yeah, I took some time. Guys, are we okay here? So we'll get this out of the way. So if the parabola is sketched for you, can you now write the equation of the parabola? And the only tough one that could show up on a quiz or an exam would be, this down here is missing. If the vertex is missing, it's gonna take some, solving equations to find the A and the B and so forth and so on. Any concerns here? Any questions at all? Now, with that said, Michael, you're close by there. Did I have right beneath it maybe, some word problems? Okay, this is me trying to finish up that chapter. And then we'll flip it over and do something else here on the, other side there shortly. But on the, word problem, Michael, do the class a favor. Now, before I erase all this, guys, I did a lot of talking. I got some input from, some students. Are we okay with this? Okay? Define the equation for the parabola. Now, as I erase, I sent my former students an email last week. I'll do the same thing to you. When you leave me, and you go to Math 7, they're in Math 7 now. So I sent them an email, and many of them responded. And it was, how are you doing? So I told them, I said, I'll find you. So I sent them an email, how are you doing? And I'm assuming that those who did not respond may not be doing too well. But those who are doing well in Math 7, they responded, oh, professor, I'm so glad you took the time to show me this. I'm so glad you took the time to do this with us. I see now the payoff is here in Math 7. So they appreciate it. So I'll be sending you an email later on to check on you. If I don't receive one from you, I know all these instructors. I know all these professors. I'll find which class are you in? And maybe I'll get a response then. I talk to the instructor and say, do you have Aaron in class? And the professor says, yeah, I got Aaron. I said, he didn't respond to my email. How's he doing? I just asked, how are you doing? And then I'll find out how Aaron's doing from the professor. See what's going on here. So guys, all this will fall into place in the calc class. Anna, Mr. Carr, before I leave this, we're leaving this, close this down. We'll move to chapter 3 here shortly. Can you tell the class what that vertex is acting as a minimum, in this case? How does that relate to Math 7, their first calc course that they're going to be taking? What are they going to do there with this?
We find the local minimum.
Find the local minimum. Are they going to actually find the local minimum without seeing the graph? Yes. Like I say, you say Ramsey sketched it for us. He went through all this sketch and lined these points up, took some input from students, and calc instructor will say, all I'm getting is this. I'm just giving you this. Now find it. Now, if you're clever, you could say, wait, now Ramsey did show me something that I could have used to find the vertex here by using what? Negative b over 2a. Or, and also what, 4ac minus b squared over 4a. Then all of a sudden you get to the calc class and they're going to show you something else real quickly. Mr. Park, Anna, let me point out real quickly so they get some little glimpse of what's going to happen. Guys, here it is. There's the equation. They may ask you to sketch it. But more than likely, they're going to ask you what is the minimum value that function takes on, and you don't see the graph. You don't have to go through all this business I've been going through, completion of the square. You don't have to complete the square. That's important. And there's another little process. Anna, Mark, tell the class real quickly, and just give them a little glimpse of what you would do if you were presented this in Math 7, and they ask you, where is the x-coordinate, and just within a few seconds, where's the x-coordinate of the vertex for this function? What would you do?
So we take the derivative.
Take the derivative. Professor, what's the derivative? I don't even know how to spell the word professor. What is it? Derivative. Derived. Looks like something derived. Derivative. All the rest you do is take this exponent out front. Or that exponent is taken out front, multiply that coefficient by that. And have 4, in this case, 2 times 2 is 4. And of course, you're left with x raised to the 1 now. Then you go down here and try to do the same thing. Move the exponent out front. By the way, the exponent's understood to be a one there in that second term. Move that out front, times that coefficient, you get a -4. X raised to what? 0. You use the one up, go ahead and move the one out front. Then you set that equal to 0 and solve for X. Within seconds. Something called interruption. If you're gonna worry about here, I thought I'd just throw that in before I leave. Okay, guys, all that said, here we'll move into, part 2. Aaron, to close this down, would you please do me a favor? And maybe the second problem on that handout. Is there one, start reading it and I'll recognize it. Read a little bit of that second problem. On the handout. How's it start? Aaron.
Part B.
Yeah, part B, start part B first.
SMC has 2,000 meters of fencing to enclose a rectangular region.
Okay, hold on, Aaron. Okay. And Michael, I'm asking you something also here, sure. And he's gonna say, okay, he has how much, how many meters of fencing?
2,000 meters.
2,000 meters of fencing. SMC has 2,000 meters of fencing. Okay, let's do this. Aaron, read just a little bit more.
If no fencing is needed along Pico, what is the largest area that can be enclosed?
Okay, now do me a favor. And we'll call on Michael since he's closer up here at the front. Aaron, read that to me one more time, starting from the beginning.
SMC has 2,000 meters of fencing to enclose a rectangular region that borders on Pico Boulevard.
And we all know where Pico is. So we'll say this is Pico here. And for some reason, you know, there's a lot of construction going on campus. He's telling me I have 2,000 meters of fencing, the construction crew does. And they want to fence in, for some reason, a little plot of ground on campus that borders along Pico. Now, Michael, read the next part, same problem.
Express the area of the flower garden as a function of W, the width of the garden.
Oh, is that the same one? No, that's a separate, that's a different problem, isn't it?
Oh, I'm sorry, express the area of the region as a function of L, the length of the region.
Okay, is that the same thing we're talking about there, Aaron?
Yeah, that's the question below.
Okay, so now read the last part of the question here.
It says if no fencing is needed along Pico, what is the largest area that can be enclosed?
Okay, so we got 2,000 meters of fencing to fence in, and no fencing is needed on Pico. And also the construction crew comes in, they have the fencing needed, and they need to start fencing. Now, they want to fence in, I think, what you said, the largest area that they can. So how can I use that 2,000 meters of fencing to benefit me so I can enclose the largest area, inside here, the largest area possible? And I need not worry about fencing along Pico. But right now, I see the width is missing, and the length of this plot of ground is missing. I don't think Aaron gave that to me. Okay. You got that so far? Now, please tell me, at this point, guys, step one, can anyone tell me, based on what he read to me, can anyone tell me in equation form, what do I know at this point? Someone tell me in equation form, based on that sketch, based on what he gave me, what do I have that I could write down now from what Aaron read to me? How many meters of fencing do we have? How many sides do we need to fence in? 3. So let's take those 3 sides the way they're labeled, add them up. So I got W plus L, so I got 2W plus L, those are the 3 sides. And that's going to require 2,000 meters of fencing. That's one relationship. Secondly, he's asked me, Professor, they're asking me to maximize the area of this plot. And if they use the word what? Maximize, find the maximum, then the first thing that comes to my mind is negative b over 2a, or vertex form. So it has something to do with what we're discussing here today. Guys, to maximize the area, oh boy, how does one find the area of a rectangle to begin with? I've got the rectangle. What's its area? Not perimeter, it's area. How does one find the area of a rectangle? Base times height, length times width. So in my case, the way mine is labeled, I would have the area, A is equal to length times width. Base times height, that's the length. Length times width, that's the area. Is that true? Now, I need now, with your help, to take this equation for the area, write it, if I can, just in terms of L or W, just one variable, and then I can apply the negative b over 2a, because I think I'm going to end up with a quadratic. I don't have a quadratic right now. Does anyone have an idea of how to rewrite this, using this, and write number 3 as, and it'll turn out to be a nice little quadratic? Yes, Bernie.
We moved the 2W to the other side.
Hang on now, so she says, go back here, Professor, and maybe solve for L by subtracting 2W.
And then we replaced L.
Look at this. And he says, hold on, if that's true, which is true, he says, Professor, take that, well said, and substitute L with that. I can make a substitution. If I do make a substitution, Vernon, thank you so much. This area now will be written as, in place of the L, she says, Professor, put 2,000, subtract 2W. That's my replacement for L. And of course, I still have W on the end, along with that substitute. And I have this to work with. You guys agree? That's my substitution. Now, if I use a distributive property, I can rewrite this as area is equal to 2,000 W, subtract 2W squared. That's my area. Is that a quadratic? And if they say maximize that quadratic, you can either use the completion of the square like Aaron likes, or I could use a shortcut, negative b over 2a. Okay, so we usually write this as x is equal to a negative b over 2a. This is in terms of w, so w is equal to a negative b over 2a. The same as saying x is equal to a negative b over 2a. Make my replacements, be very careful, it's negative. Let's turn it around a little bit. My b is 2,000. Over twice a, looks like a is a negative 2. Clean this up, it's going to be a positive answer. It's 2,000 over 4, I guess. Is it, guys? Over 4, was it? Is that true? It's a positive? And that's going to be a positive what? 500? Yeah, that's correct. That's the W. That's the width. I just found this. This is 500 meters for the width. Now, can I find the length? If I wish. I can find the length if I, oh, right there it is. Burning it to me. Just go back, find the length, the L, Professor, make a substitution, 2,000, subtract 2 times W. We think W is 500, we're hoping. Put that in as a substitute. Guys, clean this up. L is equal to, looks like 2,000, subtract 1,000. Looks like it's 1,000. Is that true? So now I have the length, 1,000. Wow. Is that true? Large numbers for dimensions, but looks like my numbers are agreeing there. Ah, my goodness. Aaron, tell me right at the end, what were they asking me to find?
X
express the area of the region as a function of L, the length of the region.
Beautiful. Now what did I do? I expressed mine in terms of W. Could I have done the same thing they asked me to express in terms of L? Could I have done the same process and expressed it in terms of L? I did mine in terms of W. What else did they ask me at the end?
With maximum area.
They say find the maximum area, okay? All right, guys, my final answer, what would the maximum area be, and times with, if these numbers or large numbers are correct? What is my maximum area of this rectangular region that we have here? Then starts with? It looks like what, 1,000 times what, 500, is that 500,000? Square? I think you said, in this case, what was it, Aaron, meters?
Meters squared.
Yeah, something right like this. Meters squared. 500,000 square meters would be the maximum area they could construct with the number of meters they were given to work with. And that is the way it's worked. Now, before we take a break here, the reason I brought this in, the reason you have it on the handout, can anyone connect this to the exam? On the exam, did I ask you guys to maybe find a maximum or a minimum, I think it's the last problem on the exam. And don't use, completion of square, don't grab it, I didn't grab this one. Can anyone tell me what could I have done? I approached mine like this. To find that 500,000 square meters area, I found the length and the width and I multiplied them together. What's another way to find it from here? What could I do to close this gap if a student wanted to do it? First, can anyone tell me a way to find the W? If I wanted to, based on what you've already done on the last exam. How could you find the W without going through what I went through? And stop right here and say, wait, Professor, I'm gonna work it a little differently and find out what that W is. What would you do? Shame on you. Could I use negative B over 2A? That's a quadratic. Now I think we have what, X equals negative B over 2A? In this case, it's W is equal to negative B over 2A rather than X. I can still use that formula that you guys used on the exam. If I'm careful, it's a negative. In this case, B is turned around, guys, it's 2,000 over twice A. A is looks like a negative 2. And looks like I'm gonna end up with 500 there, which I did here. Now, comma, how could I find out what I'm really after? The area. What do you suggest I do now? We found 500,000 for the answer. What can I do now? What did you guys do on the, I think on the exam? What could you do now? And some students did one option, there's some students on the exam took the other option. What could you do now? For those of us who don't mind a number like 500, you could take it back and where is it? Plug it in here. Do your work. Or I saw some student doing this. They were using, find it by doing this. Could I use 4AC minus B squared all over 4A? Would that give it to me? If I'm patient and plug in my numbers I need here, guys, would that give it to me? Also, so I could have used that negative B over 2A and also the other formula there for the vertex. Fine. Okay, tell me, Aaron, so that's all they asked me to do with this one? That was it? Is that true?
Yep.
That was it? Now, can anyone tell me, before I take questions, before we take a break, suppose they had not had the border of Pico, and had no fencing required along Pico, and all of a sudden they say, no, we need to fence in this side also. Is that gonna make a difference? And they still have, in this case, they still have, in this case, what was it, 2,000, I think it was? Yeah, 2,000, meters of fencing to do that. But now they need to fence in for some reason, even the side along Peak over the fence. So that right there would now be used, so that's another L up here. What might that do? So rather than saying what, two W plus L, now I'm gonna say what? Two W plus what? Two L equals 2,000. And then of course it's the same way. Anybody, fence on the other side. Okay, so I'll hang one up, yes.
How do we know Pico is on the long side?
You don't.
Okay.
You don't. Usually if I have one of these on the exam or a quiz, I usually label it for you so you can see which side I want Pico to be on,
Okay.
okay?
But doesn't that?
No, that's not, that's what you're thinking. You're thinking maybe, Pico is on this side.
Yeah,
That's right, it could be.
but it doesn't matter.
It does not,
Okay.
does not. Okay, anything else on this one? Does it make sense? You understand the thing, you're going to use a quadratic. Now, I don't think that construction crew going out there to work, I don't think they're thinking about a quadratic in their head there to find out. They have other ways to find out what the maximum area might be and how much they need to use. Okay, so hang on up.
How exactly do you write A, as a function of L?
Okay, beautiful, here we go. I got mine in terms of W. Here we go. Now, Aaron, you tell me before I leave, before we take a break here. You're saying, Professor, actually, you have this as A of W, which worked out beautifully. You're saying, though, they asked me on the handout to find A of L. Now, what must I do now? If I want the area formula written in terms of, not W, which we did through this process, I want now in terms of L. Guys, what should I do here now? Rather than solving for L, as Bernard told me earlier, go back to this and solve for what? Solve for W. So if I go back and solve for W right quick, I should go this up. This is 2W is equal to 2,000 minus L. Don't make a mistake here. Divide by 2. So W is going to be equal to 1,000 minus, let's call that 1/2 L. Let's see if you guys agree. Is that true? So that's what W would look like, and then I know the area is length times width, so I can say, hold on, Professor, if they want this as A of L, why not write this as, in place of L, got L here, in place of W, I can put now, where was it, guys? 1,000 up here. Subtract 1/2 L. Multiply descriptive property, so you wind up with 1,000 L minus 1/2 L squared. Anybody want this in terms of L? Is that true? Yes or no? If they want it in terms of L. Can we do it quickly, guys? Okay, Aaron, did they say do it in terms of L, I think? Okay, I did mine in terms of W. By the way, guys, if you use this, let me hang on just 1 second. Let me see what's gonna happen. This is L. Okay. Let's see if we can do this for big break here. Try that. L is equal to negative B over 2A. In my case, that would be a negative. D in this case is 1,000, start around a little bit. Over twice A negative 1/2. Please tell me, if I turn that up, is that positive 1,000? I think. And is that what we're supposed to get over here? For the L. So good, I've done it in terms of L or W. I did mine in terms of W. Okay. Guys, feel better now? That's what we did. You write in terms of L or W, here it is in terms of L, got things all, right here it is. That's the area in terms of L. Here's the area in terms of W. You do it either way, and end up with the same result. Wow. Okay, guys, want to take a break, 10-minute break? You guys came in late, you did not pick up your exam, I want you to pick up the exam before you leave for break. Have you guys take a 10-minute break? Next thing, chapter 3 here. You can do it for a check.
Okay, but no.
No, I'm gonna show you the work we're
Oh,
gonna do.
just someone
Okay.
asked me, what you been gonna do?
Korean barbecue. Today, and,
Hey, it's
Sorry.
okay, right?
yeah, his friend had a party.
Did you get your hand out?
But
Right
we're
here.
to be.
Yeah, so that's one good thing. Why?
And you saw your score, right? Did you get a copy of the handout?
And,
Yeah, look through and see what, I just make sure.
like, he came yesterday, he suddenly came, I was like, wow, but,
Yeah, I don't know.
But he was supposed to give it, right?
no, he was like, so it was like, we were talking, like, it's like a, yeah,
Huh?
it's like a spring break,
Hmm.
and then like,
You just should have done draft.
you can come in a few months,
Bring that on down.
like 2 months
It's
ago.
over there.
2 months ago. Saturday, like, I'm not sure, but I might come out Monday. So I'm like, okay, and it's Saturday midnight. I'm like, oh, I have a complaint. Tomorrow, okay. Like, okay. Yeah, that was a good story.
You didn't expect him.
Huh?
You didn't expect him.
Yeah, but it's fine. He's a very chill guy. He let me do my stuff, you know. How was your day?
Pretty chill.
Very chill.
The wife came in.
Oh, I can. You liked it? You like that or no?
It was okay. I was like, when I finished the soap, we went like within like 30 minutes. So like it's easy. So now I'm doing like soap and two, it's a pretty easy one. Yeah, I've been double checking and every single final what you do is like the right answer. So it's not hard. Just a little bit
Little bored?
bored.
Yeah.
That's why.
I'm like hungry as fuck.
You hungry?
Yeah, I did.
Hello, hungry. My name is Hannah.
Cool. Bro, I'm like, I only eat pickle.
Really?
Yeah.
You know what you can do? Today was like, I mean, it's already closed, but today they were giving out like bread and bagels.
Okay.
But they got,
Oh, these are big.
yeah.
That's good.
Oh, you should have, they'll maybe like tomorrow or something like this.
But I done every